Well, you always worry when divers are in the water, but iceberg diving, there's even more of that anticipation and excitement that goes on in the lower part of your belly.
So you swim in and you begin to see the details. You begin to realise that this is not a flat wall of ice going into the depths. This has tiny little dimples on it, which it almost looks like a giant golf ball.
These features are added to the models to understand how they affect the way the icebergs float and travel over long distances and into the shipping lanes.
It's good to contribute to science at a basic level like this, when the science is still developing, to come in, take some shots which help the scientists. That's really useful.
For all their unpredictability, there is regularity in the behaviour of icebergs. If you look carefully and ask the right questions, which is what science is all about. And the simplest question of all is about the most obvious part of their behaviour. Why does ice float? That's not a naive question, because no other commonly occurring solid floats on its own liquid. The answer lies in the structure of the water molecule itself.
Think of what a molecule is. Take a water molecule, for example. It's two hydrogen atoms stuck to an oxygen atom. That's two hydrogen nuclei, which have a positive electric charge, sticking to an oxygen nucleus, which has a positive electric charge. And they're surrounded by negatively charged electrons. That's what sticks the atoms together. The negatively charged electrons tend to cluster around the oxygen nucleus, leaving those two legs of hydrogen slightly positively charged. That means that those positive charges can attract other negatively charged ends of other water molecules. So an oxygen can come and orientate itself and bond to that leg. On the other side, another oxygen from another water molecule will be attracted to the positive charge and bond to that leg. On the top, you get a hydrogen in, bond into that leg. So you can see you build up structure, an open crystal structure, a shape, which is actually hexagonal. And it's that property, that open structure, which is a reflection of the underlying structure of the water molecule itself, that leads to the solid ice being less dense than the liquid. And that is why ice cubes and icebergs float on liquid water.
The hexagonal structure of ice is a shadow of the forces of nature that hold molecules together. Forces that shape every molecule of water and that create a six-fold symmetry of snowflakes.